In this video, we'll complete the air traffic controller fatigue and stress test randomized block design ANOVA problem. We have already defined what the factor, treatment, and block, the notations in the previous video. For more details, refer to the previous video. We are testing whether the mean stress and fatigue score for the three workstation systems are all the same, or at least one mean is different. And here is the sample. So each controller works in each of the three systems, and the stress and fatigue scores after they have worked in the system is recorded here. So if you compute the average for each column, you get the average stress score for each system. Copy that over. Now the overall average is the average of the entire sample. K is the number of treatment levels, and that will be count A of the treatment levels. B is count A of the block levels. In this case, block is controllers. Now N sub T is K times B. Now we're going to generate the ANOVA output for block design. So go to data analysis. Now you have to carefully select. Okay, there is one called ANOVA two-factor with replication, and then there is another one which is ANOVA two-factor without replication. The one without replication is the block design. So there are two factors. One factor is the treatment factor. The second factor is block, and that is without replication. So select the without replication. Input range must include both the labels for the treatment and the labels for the block. Click labels, and then let's put the output range right here. Click OK. So now we have two tables in the output. Okay, the first table is summary. So for each controller, how many observations, what is the sum, the average, and the variance. And then here we have for each system the number of observations, the sum, the mean, and the variance. And the second table contains the ANOVA information. So we have first one is rows. Okay. Rows, here is the controller. So we can go and type controllers, and that is block. And columns is your system. That's our treatment. And here the p-values. Okay, for block we don't need the p-value. Okay, we are not going to be testing for the block. We need the p-value only for treatment. So the conclusion is, since the p-value is less than alpha, we'll assume 5% for alpha, and we reject the null hypothesis. The interpretation is that we do have sufficient sample evidence to conclude the fatigue and stress scores are different for different system designs. We have adjusted for the differences or controlled for the differences in the controllers themselves. The differences due to controllers are already accounted for, and after accounting for the differences in controllers, the system design is significantly affecting the fatigue and stress score. So there is sufficient sample evidence to conclude the average stress score is not all the same for the three controller workstation systems after adjusting for differences due to controllers. And the probability that we are wrong, the type 1 error, is 2.42%. Now at this point, we may want to do further analysis like Fisher's LSD with Bonferroni adjustment to further analyze which of these three designs is different, which one gives the least fatigue and stress score.